Dear friends, what is a complex number to the power complex number? We shall take an example of a complex number whose imaginary part is not 0. We shall not take those numbers which are purely real, as for example, say 6, because 6 can be written as 6 plus 0 into y. So here imaginary part is 0, so we shall not take this type of numbers. We take a number which will contain at least the imaginary part. So we consider a number I. Now we shall try to find out the value of I to the power I. So for this we shall use the Euler's formula, that is, this is e to the power I theta is equal to cos theta plus I sin theta. Also we shall use another thing, x is equal to e to the power ln x. What is ln? Ln means natural log whose base is e. Now this I to the power I can be written as e to the power ln I whole to the power I. Again you see, this I is written in this form, e to the power ln I, and the power is I, so written here I. Now this is a power to power, so we can multiply this. So can be written e to the power I into ln I. So now what is ln I? This is a crazy thing. What is ln I? For this we shall study on the polar form. So we consider a complex number z is equal to a plus ib. So we can write these a plus ib as r cos theta plus ir sin theta, that is r into cos theta plus I sin theta, and we know that this is r into e to the power I theta, which is polar form of the complex number, that is a plus ib. Here you see that this r cos theta is the value of x and r sin theta is the value of y, such that a is equal to r cos theta and b is equal to r sin theta. This is real axis and this one is imaginary axis, that is the Argand plane. Now we take ln to both sides, that is ln z is equal to ln r e to the power I theta, that is equal to ln r plus ln e to the power I theta. So this is ln r plus I theta. This is the rule of logarithm, natural log. Log base e to the power I theta is equal to I theta. So ln z is equal to ln r plus I theta. Now this is a very interesting case. If I take a is equal to 0 and b is equal to 1, take a is equal to 0 and b is equal to 1. So the complex number z is equal to a plus ib will be converted to 0 plus I into 1, that is I. The complex number z is equal to I in Argand plane will be look like this one. This is the real axis, this one is imaginary axis. The complex number I is here, whose Cartesian point is 0, 1. Now this distance is equal to 1, which is the modulus of the complex number z is equal to I. Now we shall see what is ln I, because ln z is equal to ln r plus I theta, and the complex number z is equal to I. So ln I is equal to ln r, r is equal to 1, so ln 1 plus I theta. Theta is equal to pi by 2. Theta is equal to pi by 2. So ln I is equal to ln 1 plus I pi by 2. What is ln 1? You know this one. This is 0 plus I pi by 2. Therefore, ln I is equal to I pi over 2. ln I is equal to I into pi over 2. Now again we return to the previous portion. This is I to the power I to the power I is equal to e to the power I into ln I. Now ln I is equal to I into pi by 2. So we can replace this. This one is e to the power I into ln I. Ln I is equal to I into pi by 2. So this one is e to the power I square pi by 2. So I square is equal to minus 1. So I can write e to the power minus pi over 2. So which is near about to 0.20788. What's the crazy matter? I to the power I is purely real. Amazing. Thanks a lot.